Okay, good morning to all of you. In this class, we are going to discuss about moment generating function or your m.g.f of normal distribution. In our last class, previous class, in detail, we have been discussed about proof of for the normal distribution, mean, median, mode all have the same value. We have been in detail, we have been proved. So I suggest that you have to write down the note, which is very much essential for your exam point of view. So let's start today's class. That the mgf about origin is given by mxt is equal to minus infinity to plus infinity e to the power tx into fx dx. See, you just recall that mgf in general, mgf for your pmf, if we have the pmf or discrete distribution, then about the origin mxt is nothing but your expectation of e to the power t into x, or summation over e to the power tx into p of x, that we have been already discussed in our discrete distributions in our previous classes. And if we want to find out, this is about the origin. Okay, so about any point, that maybe suppose a is the point, about this point moment generating function is nothing but x minus a t will be expectation of e to the power t into x minus a. Okay, uh, this is the in general we have to write moment generating function, this one. For the discrete will be this one, and for the continuous will be how much? Continuous will be minus infinity to plus infinity e to the power tx into the corresponding pdf. Instead of pmf, we have to write on the pdf. And likewise, if we are going to consider the expectation value at any point, about any point, moment generating function of a random variable x at any about any point a, then in our continuous distribution it will be written as minus infinity to plus infinity e to the power t into x minus a into fx dx. But as we are discussing here about origin, so this will be e to the power dx into corresponding f df into dx, probability density function. So we know that the probability density function for the normal distribution is nothing but 1 by sigma root over of 2 pi into e to the minus x minus mu whole square by 2 mu square dx. Here mu is represents the mean or expectation of x, and here sigma square is nothing but variance, and sigma is represents the standard deviation, that we know. Okay, so here this term is constant taken outside the integration, and we found e to the power tx into e to the power minus x minus mu whole square by e 2 sigma square into dx. Now similar type of integration, this type of integration we done here itself, right? We have to consider here we done previously done that we have to consider this what x minus mu by sigma will be z. Consider z is equal to x minus mu by sigma, so x will be mu plus sigma z, right? That means dz will be dx by sigma, or dx will be equal to sigma into dz, right? So we have to put the values here. So 1 by sigma 2 pi, as such I have been written minus infinity to plus infinity e to the power t. Instead of x we have to write mu into sigma z, mu into sigma z into e to the power my x minus mu by sigma is considered as z, so it will be z square minus z square by 2. Okay, minus z square by 2, and dx will be nothing but sigma z, right? So here in this term you can found e to the power t mu is your constant taken outside, e to the power mu t into 1 by 2 root over of 2 pi, and this sigma got cancelled. So e to the power mu t 1 by 2 pi root over minus infinity to plus infinity. And here you can see, if I will take minus 1 by 2 common from these two terms, we can get plus z square minus 2 t sigma z dz, right? And this here e to the power mu t 1 by 2 pi to the power root over minus infinity to plus infinity e to the power minus 1 by 2, and these two terms can be written as z minus sigma t whole square minus sigma square t square. Okay, this is in the form of a minus b square. So if we are going to be consider a minus b square, so we are going to get z square plus sigma square t square minus this term. Okay, so sigma square t square got cancelled, so we can get this one. Okay, so this can be written as like this way into dz. Okay, here you can see that here minus 1 by 2, here minus, so e to the power sigma square t square by 2 can be taken outside. So here you can get e to the power mu t plus, if I am going to take e to the power minus minus plus sigma square t square by 2 outside, then it will add up. So mu t e to the mu t plus t square sigma square by 2 into 1 by 2 pi root over into minus infinity plus infinity e to the power minus 1 by 2 this one z minus sigma t whole square into dz. Okay, now here we have been considered that z minus sigma t as another function, let u. Okay, so this expression will be e to the power mu t plus t to t square mu square by 2. See, this whole is in your exponent. Okay, exponent of this one, or e to the power this plus this into 1 by 2 pi to the power root over minus infinity to plus infinity. This one here, if I am going to consider z minus sigma t is your u, then this will be e to the power minus 1 by 2 u square du, and z minus sigma t equal to u, that means dz equal to du. So instead of dz we can write du, right? Now here you can see that this expression, in which way we can write, see, e to the power mu t plus t square sigma square by 2 written as such minus infinity plus infinity, here 1 by 2 pi, 1 by 2 pi root over can be written as 1 by 1 into root over of 2 pi into e to the power, see, only u is there, we can write u minus 0 whole square divided by 2 is there, 2 into 1 square into du. Okay, so this expression is nothing but your PDF of ND. This is nothing. PDF of ND having mu or mean equal to 0, sigma, here sigma square, you just compare this expression with this expression, this one, in general the PDF of an ND. So here you can see sigma is your 1, mu or expectation value is your 0. Okay, so this expression is nothing but also called as PDF of normal distribution having mu equal to 0 and sigma equal to 1 into d mu. What is the value? If we are going to integrate minus infinity to plus infinity, that means minus infinity to plus infinity PDF into d mu will be equal to 1. So at last we got mxt or moment generating function of normal distribution will be equal to e to the power mu t plus t square sigma square by 2 whole t square sigma square whole divided by 2. Okay, so this is your moment generating function of normal distribution about origin. Now what we have to do, by using this moment generating function, we have to just verify the mean and variance of ND by considering m.g.f, moment generating function, whatever we got. So finding the moments, you just put the heading like this: verification of mean and variance of nd by considering m.g.f, or finding the moments. Okay, so the moment generating function about the origin of nd, what we found, this one, this much. And we already know that rth moment about the origin is nothing but rth time differentiation of mgf with respect to t at t equal to 0. Okay, so first moment will be how much? That will be the first derivative of mxt with respect to t, and we have to put t equal to 0. Okay, that will be nothing but your mu 1 dash. So first derivative of this one will be how much, we have to find out. Then we are going to put the 0 value for t. So d by dt of this is your mxt, e to the power mu t plus t square mu square whole divided by 2 at t equal to 0. Now differentiate this one, how much you are going to get? You are going to get this power, sorry, derivative of this one. See, e to the power ax, that means derivative of this one a into e to the x, like that. So here e to the power, this one is there, so derivative of this one will be mu plus, here t square is there. With respect to t we are going to differentiate. Okay, t square is there means it will be 2t into sigma square by 2 into e to the power that same term. Okay, at t equal to 0. So now you just put the t equal to 0. T equal to 0 means this will be 0, this will be 0, or this term will be e to the power 0, that means 1. And here you have to put t equal to 0 means this term will be 0, and we got mu 1 dash equal to mu mean. This is the verification what we intend to find out. Okay, now the second moment we are going to find out. Second moment about the origin is nothing but expectation of x square, that is your mu to 1. It can be found by differentiating mxt, moment generating function, 2 times. So d by dt of this one, because this is the first differentiation with respect to t, whatever we have here I just written over here. And at t equal to 0, again I have to derivative. You got my point? See, this is the first derivative. We want to differentiate second 2 times. Already first derivative is exist here. I just substituted this value here, and we have to find out first derivative of this one. Okay, d by dt of this one, because this is represents the first derivative of mxt with respect to t. So at t equal to 0, then now you have to differentiate this term with respect to t. What you are going to get? See, differentiation we have to consider, this is your u and v product rule we have to use. First we have to differentiate this term, mu plus 2t sigma square by 2. So mu is constant, it will be 0, and differentiation of this one. See here 2 got cancelled. With respect to t we are going to get sigma square, and and here I forgot to write here, this will be, this has to be here, e to the power mu t plus t square sigma square by 2. Okay, then we have to consider the differentiation of this one. So keep as such this one u kept here, and differentiation of this one, it will be differentiation of this term with respect to t and e to the power this one. So this differentiation of this one with respect to t will be how much? We can get mu, this is mu. Okay, this is mu mu t, sorry, mu t is there, differentiation with respect to t, it will be mu, and this one will be 2t into sigma square by 2 into e to the power this much. Now we have to put at t equal to 0. If I am going to put t equal to 0, see, this term will be 0, this term will be 0, and this will be 1, but this whole term will be 0. And here you can see sigma square into e to the power 0 will be 1. We got that. See, wait, I mistakenly I told that. See, one thing here, if I put t equal to 0, this term will be 0, this term will be 0, and this term will be 1. Then from this, how much I got? I got mu into mu square. And here in this term, if I will put t equal to 0, then you can found e to the power 0 will be 1 and sigma square. So mu to 1 we found sigma square plus mu square. sigma square plus mu square. This is the second moment about the origin. So variance we know Vx is nothing but second moment minus first moment whole square. So here you can see that we got the second moment sigma square plus mu square minus first moment we found mu. Its square will be mu square. So mu square got cancelled and we got the sigma square, which is nothing but our variance of your normal distribution. Okay. See, may you remember that the moments can be found in this method and also in our traditional method, that uh, mm, mu1 dash is nothing but expectation of x. So expectation of x, that means, as I told that here expectation of x means, see, expectation of e to the power tx. In case of your discrete, it will be summation over e to the tx into px, and in case of continuous, this will be integration. So likewise, here also we are going to consider for the continuous case, expectation of x will be nothing but minus infinity to plus infinity x into fx dx. Okay, I have to zoom somewhat, it will give you the clarity. So this is the x into fx dx. See, these things I written with pencil, but if you want you can write this one. See why I am telling that, why I written this one by pencil, that already we know that with the help of this method and this method we can found the moments. Okay, I suggest that you have to go for this one, because if we are going to find out, if we are going to consider this method, it will be somewhat lengthy process, but you are going to get the same answer, but it will be somewhat lengthy process. But I suggest that you have to write down the note by considering this one, and somewhere in your note or in your rough you can do this for your practice. Okay, so here you can found that minus infinity to plus infinity x into pdf. See, for our discrete it will be how much, this expectation of x is nothing but summation over x into our pmf, that is your px. Okay, but in case of continuous it will be x into pdf integration from minus infinity to plus infinity into dx, right? So this will be minus infinity to plus infinity x, and we have to substitute the function fx value 1 by sigma root over of 2 pi into exponent to the power minus x minus mu square whole divided by 2 sigma square into dx. Now here 1 by sigma root over of 2 pi taken outside the integration minus infinity to plus infinity x into e to the power this much into dx. Now we have to consider z equal to x minus mu by sigma. Similar procedure. Okay, so x will be z sigma plus mu, and sigma z equal to dx. Sigma del z will be dx. Just consider this one, dx will be z sigma dz sigma. Okay, now we have to put this value and this value here. Okay, so what we are going to get, 1 by sigma root over of 2 pi minus into plus infinity, instead of x we can put z sigma plus mu into e to the power, this is x minus mu by sigma considered as z, right? So it will be obviously e to the power minus z square by 2 into dx is nothing but sigma into dz, right? So here you can see that sigma and this is 1 sigma got cancelled. We found that 1 by 2 pi root over minus infinity to plus infinity. Here you can see I segregated the two terms. See, z sigma plus mu into this one is there, so I separated two terms, that z sigma into e to the power minus z square by 2 one term into dz, plus 1 by 2 pi root over minus infinity plus infinity mu, this is mu into this much dz, right? Simple steps. So sigma by 2 pi root over minus infinity plus infinity z e to the power minus z square by 2 into dz, plus mu by 2 pi root over minus infinity plus infinity e to the power minus z square by 2 into dz. Simple things is there. Here this will be equal to 0. This will be equal to 0 by following the gamma function. May you have been studied the gamma function. According to gamma function, you have to remember one these things. It is required very much, and this is also you can found in a short video, by a short video in my channel, that minus infinitive, you have to remember this one, minus infinitive to plus infinitive, and a special integration one video is there, you can found also in my channel, that minus infinity plus infinity x to the power n into e to the minus a x to the power m dx. Suppose in this format we have the integration, and this function suppose odd function, then minus infinity infinity is there, means directly I can write 0, right now. If this function is a even function, then this function can be written as 0 2 into 0 to infinity x to the power n into e to the minus a x to the power m into dx, right? Only if it will be even, then we can write 2 into 0 to infinity. Now integration of this one will be how much, that you have to remember, that is important. Here I written 0 to infinity x to the power n into e to the power minus a x to the power m dx will be how much, 1 by m. In general I am writing. So whenever you are going to face this type of integration, this is nothing but called as your gamma function, right? Gamma function. Okay, gamma function. So what will the value of this one, 1 by 1 by m, 1 by m into 1 by a to the power n plus 1 by m into gamma n plus 1 by m. And in short I am discussing about the gamma function, that suppose we have gamma n we have, that means it is your gamma symbol means this one. See, if we have gamma n, that is nothing but your n minus 1 factorial, or you can say gamma n plus 1 is nothing but n factorial. So gamma 5, so if you want to calculate, that is nothing but 4 factorial. Okay. May you have studied somewhere in your mathematics. Okay, so and gamma 1 by 2, gamma half equal to root pi. So this much you have to remember. And gamma negative integer, if you got negative integer, that will be infinite, and gamma 0 itself infinite. Okay, so in short I told to you about the gamma function, but you have to remember this one. This in general you have to remember, it is very very important integration. You are going to find out many times in your mathematics for different type of derivations. Okay, so you have to remember this one. So now here you can found this integration you can found minus infinity plus infinity. Here z e to the power minus z square by 2 I into dz. Actually this integration is written in the x format, it is in z format. So here how much, all exponential function is always even, but however z to the power 1 itself is odd function. So odd into even, so whole function is a odd function. So as I told that if this format will be, you can found in this format the integration, if this will be odd, you are directly can write the 0, so this will be 0. Okay, again I am recalling that how it will be 0, a special integration video I have in my channel, may you can go through that. Okay, now come to the second integration, this one mu by 2 pi root over of 2 pi minus into plus e to the power minus z square by 2 into dz, right? So here 2 mu, see this will be 2 mu by 2 pi 0 to infinity e to the power minus z square by 2 into dz. You got my point? Why I written 2? See here minus infinity plus infinity, but whenever I am going to consider the limit 0 to infinity, as it is a even function, so I can write 2 mu by 2 pi root over 0 to infinity e to the minus z square by 2 into dz. So this integration can be written in the form of, here 2 mu by 2 pi root over is there 0 to infinity, I can write here 1 is there. Okay, 1 into e to the minus z square by 2, so 1 can be written in the form of z to the power 0. Yes or no? So z to the power 0 into e to the power minus z square by 2 into dz. Okay, so you just compare this x to the power whatever, that is considered as n. So here z to the power 0 is considered as n, so n is your 0. And here you can see minus a x to the power m. Okay, so here x, here z, so z to the power 2 is considered as m, m is equal to 2. And here a minus a, here a is how much, 1 by 2, a is 1 by 2. So what is the value, that is your 1 by m, 1 by m into 1 by a to the power n plus 1 by m, gamma n plus 1 by m. So here it will be 1 by m, 1 by m means 1 by 2. I am considering this integral only, this integration only. So 1 by 2, 1 by a to the power n plus 1 by 2 is how much, 1 by 2. So 1 by 2 to the power n is 0, 0 plus 1 by 2, that means 1 by 2 to the power 1 by 2. Okay, into gamma 1 by 2, because gamma n plus 1 by m, n plus 1 by m, so here m is 2. Okay, so here it will be gamma n plus 1, that means 0 plus 1 by 2. You got my point? See here a to the power n plus 1 by m, here n is 0, 0 plus 1 by m is 2, so 1 by 2 to the power 1 by 2, gamma 1 by 2, right? So here 2 mu by root over 2 pi is there, into 1 by 2 is there. Here you can see 1 by 2 to the power 1 by 2, that means if 2 will be taken to the numerator, it will be root over of 2 into root pi, because gamma half I told that is root pi. So gamma half is root pi, I have been substituted over here. So after calculation, 2 got cancel, root 2 got cancel, pi, see here root pi got cancel, and I found mu. See, if I am going to compare this method and yes or no, this method is somewhat lengthy, but for finding the moment you can consider this method and this method. I suggest that you consider this method for your ND, normal distribution. Okay, so here we found the first moment, right? Likewise you can consider mu 2 dash is nothing but how much, minus infinity 2 plus infinity x square into PDF, and you have to follow same procedure and you are going to get the how much, mu 2 dash, you can get sigma square plus mu square automatically. You can try by yourself in your rough, but I suggest that two things I am going to suggest to you. You keep these things in your note, in your rough you just practice, or you can somewhere you can write these things in your note, and you have to remember this one. This integration is most important for physics and for mathematics itself. Many derivations, you are going to find out this integration. Okay, now we are going to go for the moments of normal distribution about the mean, okay. So again I am here, you can consider the two method that we know that moment about the mean is nothing but 1 dash is nothing but expectation of x, right? And moment about the mean, that is your, suppose I am going to consider mu 1, that is nothing but expectation of x minus mean means suppose x bar. Okay, so mu 1, this is nothing but moment about the or about the mean. Okay, so here in your normal distribution case, mu so here rth moment, rth moment means if I am going to consider mu r will be this much to the power r. So mu 1 will be exponent expectation of x minus x bar, or for this case expectation of x minus mu to the power 1. Okay, whatever written here. So separately here we have been evaluated the order moments about mean and even order moments about mean, right? So first we have to go for the order moments about the mean. See, mu1 is your belongs to odd order, and mu2 is belongs to even order, okay, and mu3 is belongs to your odd order. So why we done so, you can confirm at the end of the discussion. Here you can see whatever may be the order. If it is odd, that means mu1, mu3, mu5, mu7, the values will be 0, and even order moments will be this much. We are going to be find out. Okay, you just go through the derivation. So mu 2n plus 1, that means belongs to odd, will be minus infinity to plus infinity. See, is nothing but expectation of x minus x bar, or mean x minus mu to the power 1 for first moment. That means we can write for the continuous distribution, this will be minus infinity x minus mu uh, fx dx, right? So same thing it has been written. If we are going to consider 2n plus 1 order, so it will be x minus mu to the power 2n plus 1 into fx dx. Okay. So here minus infinity plus infinity minus x minus mu to the power 2n plus 1 into pdf into dx, right? Now then simple derivation is there, minus infinity plus infinity. Here you can see x minus mu to the power 2n plus 1, and the fx or pdf of nd normal distribution is nothing but this much, 1 by sigma root over of 2 pi e to the minus x minus mu whole square by 2 mu square into dx, right? So now we are going to be consider x minus mu by sigma equal to z, x equal to z sigma plus mu, dx equal to sigma into dz. We have to substitute these values. Here we can found that minus infinity plus infinity, here x minus mu is nothing but how much, x minus mu is your sigma z to the power n 2n plus 1 to the power 2n plus 1 into 1 by sigma root over 2 pi is there into e to the power, as we have been considered that x minus mu by I sigma equal to z, so this will be how much, it will be e to the power minus z square by 2 into dx is nothing but sigma z. So sigma z I have been written over here. Here you can found sigma to the power 2n plus 1, here sigma to the power 1, and here one sigma is there. So this sigma got cancelled with each other. So sigma to the power 2n plus 1 is a constant, can be taken outside, and 2 pi to the power root over also constant taken outside of the integration. Sigma to the power 2n plus 1 by root over of 2 pi into minus pi to pi z to the power 2n plus 1 into e to the power exponent to the power minus z square by 2 into dz equal to 0. Why? Because here the power is how much, z to the power 2n plus 1 is always odd, this will be always odd. Okay, that means zq, z5, z7 is an odd function always, because if we are going to consider minus of zq is nothing but minus zq. So as we know that if the function fx is there, f of minus x equal to fx, then it will be called as the even. If it will minus fx is called as the odd, that we know. So here z to the power 2n plus 1 will be always odd. So and exponent to the power whatever, that will be always even. So odd function into even function is there. So whole this function, this term will be your odd. So minus infinity plus infinity, as we discussed, minus infinity plus infinity, if this type of term will be odd, we can found, then by using gamma function this will be 0. That is z to the power 2n plus 1 into e to the power minus z square by 2 is a odd function. You have to write down in the bracket, right? Now we have to consider even order moments about the mean. That means mu 2n, so it will be minus infinity to plus infinity x minus mu to the power 2n into fx dx, right? So here you can found that now see, here you can found that by considering similar procedure, that means first you consider that this is your this is your x minus mu to the power 2n. So you can see whenever we have x minus mu to the power 2n plus 1 and we consider this equal to z and x equal to this much, dx equal to this much, at last what we found? We found sigma to the power 2n plus 1. So likewise, if we are going to consider the same procedure by substituting this equal to z, blah blah, same procedure, what we are going to get? We are going to get sigma to the power 2n, sigma to the power 2n, whatever the power here, same power will be come up on the sigma. So sigma to the power 2n divided by 2 pi root over minus infinity to plus infinity z to the power 2n, because here we have been considered 2n, so z to the power 2n, but here it is came as z to the power 2n plus 1. So z to the power 2n into e to the power minus x square by 2 into dz. So here I written by considering similar procedure whatever we have done here. So in your exam also you have to write this one, because these are the simple 2-3 steps, no need to write in your exam, it is very simple steps. Okay, that means what I'm going to tell, that here we have to put x minus here we have to put x value, then we have to consider this one, and we are going to get this one. So I suggest that you have to write down this one, because these 2-3 steps are very simple. So here sigma to the power 2n by root over of 2 pi into, here as this is even function, we can write 2 into 0 to infinity, this much, right? So in general we know that 0 to infinity x to the power n e to the power minus a x to the power m dx is nothing but 1 by m into 1 by a to the power n plus 1 by m into gamma n plus 1 by m. So here in this integral the value of m is nothing but 2. Okay, and value of a is 1 by 2, value of n is nothing but 2n, so we have to just substitute in this answer. Okay, what will the value? The value will be sigma to the power 2n is by 2 pi is already there, so we have written this one, 2 into 1 by m. 1 by m means 1 by 2. Okay, then 1 by a to the power n plus 1 by m. 1 by a is nothing but 1 by 2. 1 by 2 to the power n plus 1 by m. Here n is nothing but 2n. So 2n plus 1 by 2 into gamma 2n plus 1 by 2. Right? Now sigma to the power 2n by 2 pi root over into 2 to the power. Here you can see that these 2 got cancelled. Here 1 by 2 to the power 2n plus 1 by 2. So if we are going to take this 2 to the numerator, so it will automatically how much? 2 to the power 2n plus 1 by 2. 2n plus 1 by 2. This 2 gone to the numerator. So it will be 2 to the power. This is 2. Okay. 2n plus 1 by 2. Gamma. This is 2. Gamma n plus. See gamma 2n plus 1 by 2 can be written as 2 got cancelled here, n plus 1 by 2, right? So it can be written as sigma to the power 2n by 2 pi root over into 2 to the power 2n plus 1 by 2 into gamma n. Here 2 you just divide with each term, this will be n plus 1 by 2. 2 to the power n plus 1 by 2 into gamma n plus 1 by 2. So finally we got that mu 2n will be equal to how much? Here you can see 2 to the power 1 by 2. That means root over of 2 is there. And here denominator another root over of 2 is there. So root over of 2 got cancelled. We found 2 to the power n. So 2 to the power n, sigma to the power 2 to the power sigma to the power 2n. Sigma to the power 2n by root over of pi into gamma n plus 1 by 2. So here what we found? Here it is concluded that all odd order moments about mean vanishes. Here what we found? This is your mu 2n plus 1. Whatever may be the n equal to here equal to 0, 1, 2 like that. So odd order moment about the mean we found 0, and even order moments given by the equation 2. Okay, here even order moments about the mean I not written. You can write, you have to write u about mean. Okay, about mean given by equation number 1, equation number 2. Okay, so here in this method we used this method that by considering this one integration minus 1 to 1, this in this way we found the what moments about the mean. And the same answer you can found by considering moment generating function. See, first we have to find out the moment generating function about mean, then we have to consider the derivative method, and we are going to get the same answer. You just check it out. So we know about any point mgf is how much. Mgf is about any point mgf is m x minus a into t, that is equal to expectation of e to the t into x minus a. Okay, about the mean. So if about the point is this one, so if you are going to consider about the mean, then mx minus mu, here mu is considered as the mean for the normal distribution, t will be equal to expectation value of e to the power t into x minus mu, right? And this will be nothing but minus infinity to plus infinity. Okay, minus infinity to plus infinity e to the power t x minus mu into the PDF. This is PDF, that is 1 by sigma root over 2 pi into e to the minus x minus mu whole square by 2 sigma square into dx. See, may you are thinking that in which procedure you have to write down your note. I suggest that this procedure you have to write down the note, and this procedure you have to write in your note. Keep that as it is extra, or somewhere you have to write the somewhere in your note or rough you have to keep this one. Okay, for exam point of view, I'm telling. So here e to the power t into x minus mu is there, so t minus t mu taken outside, it is a constant, so e to the power minus mu t taken outside, minus infinity to plus infinity e to the power tx into 1 by sigma root over of 2 pi and into e to the minus x minus mu whole square by 2 sigma square into dx. Now, okay, now here you can see this much value already we have been calculated. This much value is nothing but what, mxt about the origin we have been already calculated. Okay, we have been already calculated the value of mxt. How much? This one I can write there directly. Okay, that means if I will solve, uh, then I will get e to the mu t plus t square sigma square by 2. So here you can see e to the minus mu t here into e to the plus mu t got cancelled. That means e to the minus e to the plus will be e to the 0. So it will be 1, and m x minus mu into t we found e to the power t square sigma square e to the t square sigma square by 2, right? So now we are going to consider the even and odd moments about the mean. So this value we found what, moment generating function about the mean, moment generating function about mean. So see, here I will be suggest one thing, that do one thing, it will be better. After writing this one, you put the heading that mgf, moment generating function of nd normal distribution about mean and do this derivation. Each and every step I done. So here I you just put to dot dot, and you have to write that we previously calculated. Okay, just put the dot and you have to write this one, mu t plus t square sigma square by whole divided by 2. So now here you are going to get first derivative. I am going to consider the first derivative of this one. It will give you what? It will give you mu 1, right? So just to do the first derivative, it will how much? Derivative of this one, that means 2t into sigma square by 2 into e to the power t square sigma square by 2. So now put t equal to 0. After derivative, we have to put t equal to 0. If I will put t equal to 0, I got the 0. So mu 2, sorry, mu 1 moment about the mean. Moment about the mean, I found first moment about the mean, I found 0. Now we have to go for the second moment. So already first derivative I have been done. So the second moment, that is your mu 2. Mu 2 is nothing but second 2 times derivative of your moment generating function, and we have to put t equal to 0. Already first derivative we have this one. Another derivative we have to consider. That means here sigma square by 2 taken outside, and 2t into e to the t square sigma square by 2 derivative we are going to consider. You see, uh, consider the product for formula. Here 2t kept as such, and derivative of e to the power t square sigma square by 2 will be nothing but 2t into sigma square by 2 into e to the power t square sigma square by 2. Okay, plus plus uh, uh, we have to consider derivative of 2t. Okay, derivative of 2t, then derivative of 2t will be 2 with respect to t, 2, and this one e to the power t square sigma square by 2, e to the t square sigma square by 2, right? So here after doing this we have to put t equal to 0. Here you just put t equal to 0. What you are going to get? Here t terms are there, so this term will be cancelled out. Okay, this term will be cancelled out, and outside one sigma square by 2 is there. And if we have to put t equal to 0, so e to the power 0 will be 1. So sigma square by 2 into 2 will be how much? Sigma square. We found the second moment about the mean is nothing but so called variance. Likewise, if you are going to consider d if you are going to consider dq mx minus mu t by dtq I forgot to write this dt square. Okay, dtq at t is equal to 0, you can found 0. This is the odd order moment about the mean. And d4 fourth time derivative with respect to t, if we are going to consider for m.g.f moment generating function about the mean, then you are going to get the value. You just try in your rough, and you can found accordingly. Okay, so here we confirm that the odd will be odd order moments about the mean will be 0, and even order we can get the answer. Okay, so in general this way we have been derived that things. And after writing this much, you have to write these things by putting the heading mgf of md about the mean. Okay, so here we have to stop our today's lecture, and in our next class we are going to do some numericals on normal distribution. So thank you so much for watching this video. Thank you.